In this video, I will teach you how to write electronic configuration of ions confidently. So look, at first I will show you the electron configuration of magnesium 2+. You know that magnesium is an element whose atomic number is 12. So we have to write the electron configuration of magnesium 2+. So to write the electron configuration of magnesium 2+, you need to write the electron configuration of neutral magnesium. In neutral magnesium, you have atomic number 12, means this has 12 proton and 12 electrons, right? The number of proton and electrons is equal. So let us write the electronic configuration of this neutral magnesium first. So you need to memorize this sequence: SS, PS, PS, just twice, SS twice, PS, PS. Consider this PS as a unit, this PS as a unit, and write it twice. Then DPS, DPS. Consider DPS as a unit and write it twice. Then write FD, PS, and this will continue. That is, you have to write SS, PS, PS, DPS, DPS, FDPS, 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 right? Let us help your memory. SPDF. This is your first subshell, then second, then third, then fourth. So S can hold maximum 2, P can hold 6, 10, D can hold maximum 10 electron, and F can hold maximum 14. So you have 12 electron for magnesium. So let us distribute 2, 4, 6, 10, then 12. So you don't need this sub-level. You know that S subshell start with 1, first shell, right? 1s. So second S will be 2s, then 3s. P subshell start with twice P. So you don't need any subshell. So this is the first way to write the electron configuration of magnesium. Here you can use this diagram to write the electron configuration of magnesium. Look, when you are drawing this line, you need to draw this line at 45-degree angle. So this line and this line is perpendicular to each other, so you have to bisect this angle. So this is 90-degree angle, but if you bisect this angle, then this is 45, this is 45. So 2 electron will go from here, 1s, then we have to move here, then 2s2, then we have to move here, 2p6, then 3s2. So already we have used these 12 electrons, right? Okay, so let us save here. Now we'll write the electron configuration of magnesium. So we need 2 plus means here we have 12 protons and the number of electrons is 12 minus this charge 2, that is 10. So we have 10 electrons for magnesium 2+. So that is, we need to remove 2 electrons from here. So from where you will remove the electrons, this at first you have to remove electron from the highest value of n, and then in some case you have to remove electron from the highest value of n plus l. You know that the value of L, 0 means S subshell, 1 means P subshell, 2 means D subshell, and 3 means F subshell, right? So look, if I write the highest value for these 2 subshell, highest value of n equal to 2, and n plus for this subshell is 2 plus 1, that is 3. And for here the highest value of n equal to 3 and n plus l equal to also 3. So to remove electron, at first we'll electron from the highest value of n. So highest value of n equal to here. So 2 electron will go from here. So So 1s2, 2s2, and 2p6 is the electron configuration of magnesium 2 plus ion. Okay. Now write the electron configuration of calcium 2 plus. You know that the neutral atom of calcium has 20 electron because its atomic number is 20. So let us write the electron configuration of calcium. So we have to write SS, then PS, then DPS, then FDPS. Actually, this is the fastest way to write the electron configurations. We have 20 electron, so 2, 4, 10, 12, 18, 20. So we don't need this subshell. So S start from 1s, then 2s, 3s, 4s, and P start from twice P, then 3p, right? Also, you can do the electron configuration of calcium using this diagram. So 2 electron will go here, 1s, then 2s, 2, then 2p, 6, then 3s, 2, then 3p, 6, then 4s, 2. So if you add, then you will get 20 electrons, right? So now we have to write the electron configuration of calcium 2 plus. That is, calcium 2 plus has 2 electrons less than the neutral atom. That is, it has 18 electrons, right? But it has 20 protons but 80 electrons. So 80 electrons will neutralize 18 protons, but will have 2 more protons. So the charge of proton is here. So the electron will be removed from the highest value of n. So here highest value of n equal to 4, right? So, or the highest value of n plus L here is 4 plus 0, that is 4, right? And the highest value of n here is 3, and n plus L value 3 plus 4, n plus L equal to 4. So at first we'll remove electron from the highest value of n. So electron will go from this subshell, that is 4s subshell. So if you remove 2 electron, then this is the electron configuration of calcium 2 plus. So remove this. Now this is the electron configuration of calcium 2 plus. I think you've understood the basic things of writing electron configuration of ion. So let us take more complex ion like phosphide, right? Phosphide ion, P3 minus. So we are going to write the electron configuration of this. So you know that at first we have to write the electron configuration of neutral atom or element. So phosphorus atomic number is 15. So we have to write the electron configuration. So write this sequence SS, PS, then DPS. I think this will be enough, right? So S can take maximum 2. So P can 6. So 8, 10, 12. Then if I place here 3, 12 plus 3, 15. So actually we don't need this. S start from 1s, then 2s, then 3s, and P start from 2p, then 3p. So if you open this, electron will come here. Look, 1s, then 2s, 2, then 2p6, 3s2, then 3p3. Okay. Okay, let me minimize this so that we can have more pairs. So now we need to write this electron configuration of this. Look, this phosphorus has 15 electrons and 15 protons, but this phosphorus has 15 protons, right? But since there is a negative charge here, so it will have 3 electrons more, that is 15 plus 3 for this negative charge, 18 electrons. So this phosphorus has 18 electrons. 15 protons neutralize 15 electrons, but you will have more 3 electrons. This is the sign, right? So this additional 3 electron will enter into the highest value of N, or N plus L. At first you have to look for this, then this. So the highest value of N for here is 3, and here also 3. The highest value of, now since we are getting highest value of N, now we'll look for N plus L. So N plus L will be here 3 plus 0, that is 3, and here 3 plus 1, that is 4. So electron will enter here, and you know that S can hold maximum 2, so it is filled, but P can hold maximum 6, but here we have 3, so more 3 electron will come here. So this will be 6. Now this is the electron configuration of phosphide ion. Okay, now let us take another example so that you can have confidence. This example, nitride, N3-. You know that in a neutral atom of nitrogen, its atomic number is 7. This means that it has 7 electrons. So we can write like this: 1s, then 2s 2p, 3s 3p 3d. S can hold maximum 2, P can 6, and D can 10. Now 2 electron will go here, 1s2, we have 7 electron, then 2s2, then 2p, 2 4 3. 2p P can handle 6, so we have to need here 3 to add up 7. So 2 4 3, 7 electrons for nitrogen. Okay. Now this nitrogen has, look, its atomic number is 7. This is fixed, that is it has 7 protons. But this, for negative charge, this nitrogen has 7 plus 3, that is 10 electrons. 7 protons neutralize 7 electrons, but we have 3 more electrons, right? That is why we are placing here 3-. So this additional 3 electrons will enter into the highest value of N, or N plus L in the second step. So highest value of N here is 2. For here 2, and for here also 2. The highest value of, since we are getting 2 similar value, now we will look for the value of N plus L. The value of N plus L for twice S equal to 2 plus 0 is 2, 2 plus 1 is 3. And look, so electron will enter here, and look, S can handle maximum 2 and P can handle maximum 6, right? So you can add more 3 here to write the electron configuration of nitride ion. I think you have understood the electron configuration of nitride and how to write that. Now we'll write the electron configuration of iron 3+ and iron 2+. Look, so we'll write the electron configuration of iron 2 plus and iron 3 plus. So before writing the electron configuration of these two ion, we need to write the electron configuration of neutral ion. You know that the atomic number of iron is 26, so let us write SS, PS, PS, then DPS, DPS. Okay, so S can hold maximum 2, 4, 10, 12, 18, 20. We have 26. This is 26. So we don't need this. S start with 1s, then 2s, 3s, 4s, 4s, right? 4s, yeah. 4s. And P start from 2p, 3p. Then D start from 3d, 3d. So this is the electron configuration of neutral iron. So to write the electron configuration of iron 2 plus, we need to remove 2 electrons from this. So how to remove 2 electron from this neutral? So electron will go from the highest value of n. The highest value of n for 4s, the highest value of n here equal to 4. The highest value of n for this subshell equal to 3. Now consider n plus l. The highest value of n plus l for 4s equal to 4. The highest value of this 3d equal to 5. So n and n plus l indicates the higher energy. The number, the more higher the number, the more the energy, right? So electron will be removed from the highest value of n first. So highest value of n equal to 4 here for 4s2, right? So for Fe2, the electron will go from here because the highest value of n equal to 4 here. So this is the electron configuration of iron 2 plus. If you look, if you remove this, then this will be clear to you. So this is the electron configuration. This is the electron configuration of this iron 2 plus, right? Iron 2 plus. So again, I will take this thing here. This is the electron configuration of neutral iron. Now we'll find out the electron configuration for this iron 3 plus. So we need to remove 3 electrons from the neutral iron. So how to do that? So 2 electron will go from the highest value of n, that is 2 electrons will go from here. Then next, look, here we have 3p, then 3d. So the highest value of n plus l, for 3p we are getting 3 plus 1, 4, and here we are getting 5, right? So we'll remove one more electron from the highest n plus l value from here. So here we have to write 5. So if I delete this, now this is the electron configuration of iron 3 plus. Okay, let us try our next example. That is, we have to write the electron configuration chromium 2 plus and 3 plus. Here chromium 2 plus and chromium 3 plus. So our first duty is to write the electron configuration of neutral chromium. So write SS, PS, PS, then DPS, DPS. So distribute 24, 2, 4, 6, 10, 12, 18, 20. Then here we'll have 24. So S start from 1s, then 2s, then 3s, then 4s. Then P start from 2p, 3p, right? P start from 2p, 3, and D start from 3. Look, this should be the electron configuration of chromium, but this is not the actual electron configuration of chromium. Look, here the highest value of n equal to 4, right? Here for 4s, highest value of n equal to 4. The highest immediate highest n plus, the immediate highest subshell is 3D. Okay, the highest value of n here equal to also 3, but here the n plus L value for 4s equal to 4 plus 0 equal to 4, and here 5. So the energy difference of 3D and 4s is near, right? That is why, you know, D can hold maximum 10, but the half of D, half of 10 equal to 5. This means that half filled and full filled D orbital, D subshell is stable. That is why D4 will be D5, that is after D4 will be D5, and 4s2 will be 4s1. That is from the highest value of n, one electron will go to the near subshell, that is 3D. So this is the actual electron configuration of chromium. This is exceptional, right? So to write the electron configuration of 2+, you need to remove 2 electron from this neutral atom. So look, electron will go from the highest value of n equal to 4. So one electron will go from this subshell, and another one will go from the highest value of n plus L. So here, so this will be 4. Right, this will be 3D4. So this is the electron configuration of chromium 2+. So what will be the electron configuration of chromium 3+? For chromium 3+, you need to remove 3 electron from neutral chromium atom. So for 3, 1 electron will go here, and another 2 will go from here. So if you subtract 2 here, then you are getting this 3, right? So this is the electron configuration of chromium 3+. I think you have understood how to write the electron configuration of ions.